All right. Well, good morning. As you have already learned, or may already know, I'm Janet Meyer, and I manage the horticulture part of the Berea College Farm. And I had an amazing opportunity to spend a week in the Netherlands learning about protected environment or controlled environment horticulture. And just some background on the Netherlands. It's a country that's about a third the size of the state of Kentucky. It actually, if you take it and put it on a map of the Netherlands, also known as Holland, and you pop it over eastern Kentucky, it's about the size of Appalachia, or even a little smaller than Appalachia. It's also very flat. 26% of the country lies below sea level, and therefore the country has developed a system of canals and the iconic windmills of the area that would pump the water out so that they could utilize land that would otherwise be useless. So they were early innovators of farming by draining land that was just swamps and bogs. During World War II, 1944 and 1945, the country was experiencing severe starvation. They were encouraging people to go out and forage for acorns and chestnuts to survive. And the government decided, we will never again let this happen. And we're going to consolidate our tiny farms, and we are going to bring in technology, and we are going to make a country that is the best country in the world to provide food for its people. And the United States helped with that through the American Marshall Plan, providing them with tractors and technical assistance. They now, when they talk about agricultural developments in the Netherlands, everywhere I went, everyone talked about the triple helix or the quadruple helix approach to development, and that includes government, business, educational institutions for the triple helix, and then another layer adds in society. So they're very concerned about the well-being of the people in the community, and that they call the quadruple helix. So it's different than the way that the United States deals with research. We tend to have all these different separate areas, but they try to get everybody to work together, and I think that's one of the reasons why their technology is so well developed. If you have questions and you want to stop me.
I'll just mention that on the questions, you all have question number 4 is kind of gets at that helix that Janet just mentioned, but the article that you all read really largely focuses on the educational institutions and business or industry as the two important parts there. So anyway, that's what that one is trying to get
at. Another thing that I encountered everywhere I went, everybody talked about the UN 17 goals to transform our world, or the Sustainable Development Goals. And I'm not going to go over each and every one of them, but I was surprised. I've seen some of these emblems on products I've purchased, like maybe I've seen the life below water on a package of salmon or something, and it would indicate that that was sustainably produced salmon, but I don't see these being used in the United States, and I might say maybe Berea College would want to adopt these as goals for themselves. I think they're excellent goals, and we should all be concerned about these things. I think, have you encountered those in any of your classes or anywhere on campus? I think some people who've taken sustainability and environmental studies courses have encountered these, but most other people have never heard of them, and I hadn't really either. The largest food producer in the world is the United States, but as you will see from this, the United States has a huge land mass. And so obviously we have the capacity to produce a huge amount of food. You've got the Netherlands, number 2 world food producer, and they have an extremely tiny land mass. It's a spectacular level of productivity. And large part of that is due to their controlled environment horticulture, but they're also extremely good at arable farming or growing crops on the land that's outside, and very technologically advanced. And this is just like a reminder about the article you were asked to read. I'm not going to talk a whole lot about that. We do have a little video to watch. Let's see if I can.
70 times. But it's big when it comes to making food. Remarkably, it has the second largest agricultural exports in the world, mainly through being able to produce vast amounts of food on tiny plots. Here's how the Dutch learnt to feed the world. The Netherlands isn't exactly designed for mass farming. Because of limited space, farmers have learned to eke out as much as possible from the land. With a third of the country under sea level, the Dutch mastered how to make land using levees and built windmills to drain marshland to create fertile soil. This area just outside of Amsterdam, Flevopolder, is the largest artificial island in the world and didn't exist half a century ago. Nowadays, over half the ground in the Netherlands is used for agriculture. It makes more food than its people can eat. There was a time when the Dutch faced starvation. 1944, and the Allies begin to liberate Europe. The Nazis occupy the Netherlands and begin a blockade of the north. It created a food shortage so severe the Dutch government encouraged its people to forage for acorns and chestnuts. Tens of thousands perished from famine. After the war, as the Dutch rebuilt, ensuring food security became a priority. The issue was important to the new Minister for Agriculture, Sikko Mansholt, a former farmer and a resistance fighter in the war. He'd begin to drive changes that would turn farming into big business. Before the war, Dutch farms operated like those in most other countries. Small plots had a few livestock and produced a mixture of seasonal crops to service local populations. Mansholt wanted mass production and built on a decades-long system of state support for farming. He pursued a policy of land consolidation. Larger, more productive farms were encouraged to absorb smaller, less profitable farms. It was all about using less labour to improve yields. In 1963, the government launched a fund to help older farmers sell up and to help young farmers start new businesses. State funding into research and technology such as fertilizers and machinery followed, and thanks to aid from the US Marshall Plan, numbers of tractors rose quickly, helping farmers work more land. Dairy production grew fast as cooling tanks and milking machines were invented. In 1960, the average Dutch dairy cow would produce 4,200 kilograms of milk per year. In 2007, this had nearly doubled to 7,880 kilograms. Oversupply of milk wasn't a problem. The dairy board created Joris Driepinter, and he encouraged kids to drink plenty of it.
Nou, heel gewoon hè, 3 glazen melk per dag.
But technical innovation didn't stop with machines. The Dutch pioneered specialist greenhouses, creating conditions that would result in many more plantings than ever before.
These greenhouses are in the southwestern section of the Netherlands, and they enable farmers to grow crops the year round. With temperature and humidity carefully controlled, an elaborate water system keeps the crops properly moist.
If you were to put all of the Dutch greenhouses together today, they'd cover an area the size of Manhattan.
Farming under glass, another example of Dutch ingenuity.
Then, a huge discovery in 1959. The vast Groningen gas field would offer greenhouse horticulture a huge boost. Farmers profited from the cheap energy as their crops benefited from the heat and the added CO2. The Netherlands now has the world's highest yields per hectare for cucumbers, chili peppers and tomatoes, all carefully picked for their profitability. Reducing water use is part of making efficiencies too. Today, some farms use just 4 litres to grow a kilo of glasshouse tomatoes. The global average is 214 litres. All this built on a rich culture of farming that already existed. The Dutch were master breeders of plants and livestock and were a nation of traders thanks to the ports at Rotterdam and Amsterdam. The state built on this expertise to transform farming, including a focus on education and research as part of a holistic approach to benefiting the entire industry. It hasn't all been good though. The Dutch have been criticised for getting ahead with over-intensive methods and using synthetic fertilisers to boost production. They're now working to change this. In 1999, the country used more fertiliser than any other European country, spreading on average 500 kilos per hectare. By 2014, though, that figure had more than halved. By working together, farmers, scientists, businesses, and the state turned the Netherlands into a world leader in modern farming. Its knowledge and state-of-the-art technology will be vital in tackling the future of a rising global population with billions more mouths to feed.
Go on, here we are. And here's an interesting slide. In the Netherlands, they were using these little cold frames at one point. Berea College, we were growing 60 acres of vegetables, and we had some cold frames. I think this is being heated with some firewood. What's interesting is the Netherlands went from this, and we went from this, and then we didn't keep advancing. Yet the Netherlands kept advancing wildly. An early example of a greenhouse in the Netherlands. These are known. This is known as an orangery. So at one point, when it would be like the Dutch Indies Company would go out and search for new plants, and perhaps the wife of one of these trader invaders would say, "Bring me back some plants, honey." And so she needed a greenhouse. And so this would be an example of a very early greenhouse. So it's basically a building with a lot of windows. And so this very wealthy person, the finest gift you could bestow on somebody would be an orange. So this is an example of very early indoor production. Then they had much more extravagant, but you can see that the building is still made with brick and concrete. Even the windows were framed in with strips of concrete in this old glass house. So they were very early innovators. Also, these buildings that were of this style were considered extremely ugly when they first showed up, and the people in the Netherlands just despised all this stuff. But now it's a center where people want to come. The Botanical Garden in Amsterdam, people come and see it from all over the world.
That's one botany designer, but there's no exception to that.
And now they have just massive. So when you are driving through the countryside, it's like there will be houses snub up against miles of greenhouses. Some places it's just like miles of greenhouses. Massive. So when you are driving through the countryside, it's like there will be houses snub up against miles of greenhouses. Some places it's just like miles of greenhouses, but other places it is, like somewhat smaller greenhouses, but there are houses like these old Dutch houses, and there's a greenhouse right behind it, and interspersed with canals. If you've ever been to Ohio, the appearance is the flat part of Ohio with canals all over, and then old houses like you see in the article from the National Geographic, and the greenhouses interspersed all through there. And this one, I would have tried to show a video of where we were driving on a bus, and you could just see this. So that greenhouse, you can see like they do often use gas to produce heat and generate electricity, and they are capturing the CO2 as they're doing this, and using the CO2 to enhance the growing environment inside of the glass house. So there's and water tanks here. They collect the water off of the glass houses, and they collect their runoff water, and they filter it and clean it and reuse it. That's how they're getting the efficiency of having those extremely low amounts of water compared to like field production. One of the businesses that we looked at, we weren't allowed to walk around out in the greenhouses, and I found that to be the case in several of the greenhouses there. We're not permitted to walk around in there because we might bring pathogens or pests into the greenhouse, and so they are very cautious about doing that. This is the world's largest producer of the Phalaenopsis orchids. They raise 8 million orchids a year. I don't know if I need to read off the rest of the information on there. We could all. Okay. Another place that we visited was Surthon, and they were developed or established in 1896. So this is relative to the terms of our businesses here. This is a very old business. Of course, when was Berea College established? Anybody know? Yeah, so Berea College is a little bit older than this business right here. And they talked about food for their motto is for food, for flowers, for sure. And they're greenhouse developers, and they're also working on developing things. In this picture, these are tomato plants. So instead of having a giant tall tomato plant, this is more like the size of a strawberry plant. Now, they haven't developed the seeds. They work with someone else who's developing the seeds, and they're testing the technology in container farms. So I don't personally think container farms are a great idea, but it does show you that perhaps we can manipulate a plant so much, and this is all done with standard breeding. This is not genetically modified because they're allowed to research doing GMO, but they're not allowed to have anything like that on the market. It's extremely controlled. Genetic modification in the European Union is not okay right yet. And so so they're thinking you can get a tomato plant to produce a tomato faster and raise your tomatoes small, so you can raise more tomatoes in a smaller space than tomatoes that grow on a long stem. Another example of the production, this is also in a container farm at Surthon. They're raising raspberries indoors, and you can see the lighting, and you can see this weird little blue light, and you can see these other lights. It really is this very odd color. This is not just a faulty photograph, but they are choosing the wavelength of the light because it impacts how the fruit grows or how the leaves grow. And so they're studying and testing that sort of thing. And you might notice here they use biological control in their greenhouse to control the pests because they use bumblebees to pollinate their crops. And you can't spray pesticide for your pests and have your bumblebees in there. So they're virtually using no pesticides in these greenhouses. Here's another example from this container farm of this is strawberries that are grown in substrate. I don't know how familiar you all are with strawberries, but these strawberries were all produced from strawberry seeds. And you can see this is a sizable strawberry. This is like a normal edible. All the strawberries that I've ever known in the U.S. that are grown from seed make tiny, tiny strawberries, like they're alpine strawberries. Well, they have at least 2 or 3 different varieties of strawberries they're testing that are grown from seed. And you might wonder, why would you bother, or you may not, I realize, be aware that all of our strawberries here that we're growing at the college and probably across the United States are grown from tips. So there's a big concern about spreading viruses through those little tip cuttings. So these have to be produced. You have to use a lot of pesticides to control the probably aphids that would spread viruses to the strawberry plants. It's difficult to grow them organically. The seed is not going to have that virus. So if you're producing strawberries from seed and raising that strawberry plant from seed, you can get a disease-free strawberry plant. So you see multiple things here. So we've got substrates that you're looking at. This is in a potting media, and I'm not sure what these containers are called. There's some kind of growing bucket. And then in this one, you can see that there is a different kind of substrate they're growing in. I think that's in a rock wool block in that picture. And the one that he has pulled out is actually growing without any soil at all. It's in like a little foam container, and that foam container sits down in a block, and water, continuous flow, just runs under there through the roots. So it's a soilless production system, and it just recirculates the water, filters it, and it's continuously feeding and running through. So it's pretty amazing. And this is a very small facility, so it was really amazing to see all the research they were doing there. This is a better picture where they show the substrate, and they recycle all of this substrate. That one is rock wool. It's kind of like fiberglass if you've never encountered rock wool. And then this is a vertical production, so you can use a lift to get up there to harvest the ones that are higher up. And more container farming. You have traps for monitoring insects, and trying to see what else is in that. Oh, these things underneath them, that's for airflow, to keep good air circulation. And these are more strawberries that were produced from seed. And it's pretty spectacular. And it's also pretty spectacular not to have to bend over or crawl around on the ground to harvest a strawberry. You can just walk along, and somebody was in there harvesting the samples, and they're just dropping them right into the container, snipping them off with scissors. You don't even have to bend over. And when I said, wow, that looks so good, they were like, yeah, and we've got greenhouses where the strawberries come to you and you sit in a chair. And I'm like, I didn't get to see that, but, you know, if you've ever picked strawberries for like an 8-hour day, you would know why you don't want to, like, pick strawberries that are growing on the ground. The greenhouse is here. Well, we have the tables, and it is in my plan. Yes, not hydroponic, but soil container grown strawberries. Yes. And this is a fertilizer container. This was they were testing an organic liquid fertilizer. And here's the bumblebees that they have to release. The bumblebees can fly around in there. This actually had an electronic door, so when they have visitors coming that day, they can just close the bees in there, and then you can let them out at a certain time. So you can lock them up when you're not even there. And then they won't be flying around when your guests are wandering around your strawberry greenhouse. We have bees in the greenhouse down at horticulture, but they're very docile, and I'm not really concerned. But if I wanted to pay a lot of extra money, I could have gotten a remote control thing to open and close the hive. That's a little closer view there. And pollination is essential for strawberry production. You cannot grow strawberries without pollinators unless you want to hand pollinate each and every flower out there. And that sounds like a pretty crazy idea. Oh, I skipped one. So we kind of changing gears here a little bit. Oh, I can't go backwards. We visited the World Horti Center. It's a permanent trade show, just displaying all different kinds of equipment that is available. There were seeds available. But what I found strikingly different is just that this is a huge facility. It had an educational component, a research component, and a trade show component, all in the same giant building. So there's students taking classes there, and there's research going on one side, and there's a trade show smack dab in the middle of it, so that you can go out there and pick out what equipment and people there to assist you. during, like regular business hours. So and here, if I want to go to a trade show for floriculture, I think there's one in Ohio I've attended years ago. It's probably the largest trade show for floriculture in the U.S., but I could be mistaken about that. And I think that's in Columbus, Ohio. Examples of the technology that they have, different lights. So you would talk to somebody about, I want to grow, tomatoes, and what lights could I get? And these light fixtures are very expensive. So you've got LED lights and you've got high pressure sodium lights. This is an example of, so when you're using beneficial insects in your environment, so say you need bumblebees to pollinate your tomatoes or your strawberries, and you're bringing in beneficial insects to control your pests, so you're not using any pesticides. You don't want your bumblebees to fly away, and you don't want your beneficials to fly away, and you don't want any pests to come in either. So they have these ventilation systems, but they have screens on them. And we don't have anything like that at our greenhouses. We're not that high tech. And I would say that everything that I saw in the Netherlands about we can do this high-tech things, it's also balanced with, is there an economic reason for it? So it's not just we can do this. It's the maximum that we can grow. It's this is the maximum that we can grow. And these are the conditions under which, we might be able to get the best growth by doing this, and this, but it would cost this much. So they look at the cost-benefit analysis of all of the technology that is used, or the inputs, fertilizer or anything like that. We visited a campus called Brightlands Campus in a town called Venlo, and you can see that the entire campus was inside a giant greenhouse. They did a lot more study of things like childhood nutrition and chemical analysis of the products. This was not as interesting to me as some of the horticulture production, but it was interesting. The Wageningen, I feel like my slides are slightly out of order here. So WR stands for Wageningen Research, and they have multiple different. Wageningen is a agricultural university. I think it was listed as the top agricultural university in the world last year. Oh, you did too. Okay. So they have all different kinds of research, and the only thing that we saw was the greenhouse research, but there are many different kinds of research there, agriculture. Research. We visited their university and research farm, which is a large complex with multiple different areas of research in there. And one thing that I noticed, and I don't think I have a picture of it, is that all throughout their research greenhouse, they had advertisements from the different companies that support the research. And I don't see that in American universities. So they're very knitted together, the commercial operations and their educational programs. This one shows more strawberries grown in the greenhouse. You can see the little can of beneficial insects. You can see the airflow through there. You can see additional lighting in here. So this is a research greenhouse, and they would be testing maybe the different lighting, the duration of the lighting, how the beneficial insects are in there, or how long the beneficial insects do their job in the greenhouse. I keep pushing too hard, and I don't seem to be able to go backwards. more information says these were strawberries. We got to look, or not strawberries, tomatoes. We got to look at how the tomatoes are grown. You're not going to see this in anybody's garden. They're stringing these tomatoes up, and then they drop the tomato plant down, and you'll see the stems drop down. And so by the time they're finished growing this crop, they're thick, like ropes of stems laying around. So remember the picture of the tiny tomato plants? They want to get away from having to do all this structure. You have to have a structure that will hold up all the weight of all these tomato plants hanging from beams in the greenhouse. And there's another view of it. I like this guy. He's like, look at the tomatoes. Here. So these tomatoes were delicious. They did actually give us some to eat. And I was like, oh, wow. So they're developing their varieties for the nice balance between the sweet and the tart flavors of a tomato, and just really excellent. You might also notice that there are no leaves on the lower part of the tomato. You have less disease when you get rid of those leaves. You can tell also by looking at this that taking care of tomato plants takes a lot of work, because they've snipped off all these little leaves by hand. And all throughout their research greenhouse, they had posters talking about the different kind of research they were doing. Like we have posters, or we have the screen upstairs talking about different internships that people have done. So if I had had more time, I could have read them, although some of them were in Dutch, and I can't quite read that. So I loved this poster, No Life Without Plants. Definitely true. And all throughout their research greenhouse, they had posters talking about the different kind of research they were doing. Like we have posters, or we have the screen upstairs talking about different internships that people have done. So if I had had more time, I could have read them, although some of them were in Dutch, and I can't quite read that. So I loved this poster, No Life Without Plants. Definitely true. And more research papers, research into verticillium. Verticillium is like everywhere. We can't really get away from it. And different plants have different resistance to it. And then you can have, the pathogen can jump to a different plant that it doesn't normally infect. Research, or not so much research, but where they're looking at safeguarding the genetic resources. So there are seed banks all over the world trying to conserve the genetics, because we don't know what genetics we may need in the future. So if there are people actively growing out varieties and cycles and maintaining the genetic resources. This is an example of something they had set up in that university research greenhouse, just a display, different ways insects are used. So you have all these beneficial insects to put out in your greenhouses, but also you can make insects into like food patties. Like, anybody want to try some insect schnitzel meat, insect meat? Or we have insect nuggets. Would you eat that? I would try it. I mean, it might be good. Who knows?
A lot of livestock feed.
Oh, yeah. Mm-hmm. Yep. And here, one of their main things they were doing, so instead of just continually buying the beneficial insects, they were looking in this research greenhouse of keeping a standing army of beneficial insects in there by growing some plants that serve as a home for the beneficial insects. And that way they can continue to maintain that population. So as soon as there are pests in the greenhouse, these beneficial insects go out there and search for the pests. And this way you don't always have to buy new beneficial insects. And I had no idea before this that Gerber daisies were grown like this as cut flowers with big long stems. Kinds of neat. Oh, I did it again. I don't know how this happens. I keep skipping slides. Okay. More research that they do in these greenhouses are energy, how we use our energy in the greenhouse. We have, I think they were talking about having a fossil fuel free greenhouse. I don't know that I actually saw that, but they have developed a special kind of glass that they can collect the heat. So in a way, it's like a solar panel. And I'm like, okay, so they're collecting the heat with the glass that's also protecting the crops. And then that heat is being transferred into water, and they're storing the hot water underground. And then in the winter, they're pumping the hot water back out of the ground. So they have sand reservoirs, basically. So it's not a container. They haven't dug a giant hole and filled it up. It's just like a well. So they pump the hot water from summertime into the ground. It stays hot underground, and then they pump it back through the greenhouses in the winter. And they're also, then that water gets cold, they pump it into a different spot, and then they're pumping the cold water out in the summer to cool the greenhouses. So we have geothermal cooling in some of our buildings on campus, so it's like that idea maximized. So it's really fascinating to me. I did talk about the standing army already. You are allowed to ask questions if you want to ask questions. So this is examples of the they call these silos. They're storing their water in silos. This actually might not work in Kentucky. If I recall, they are zone 8 in the Netherlands where we were looking at this, so it doesn't get quite as cold. In that video, they showed these incredibly snowy, snow-covered greenhouses, but they have not had cold weather like that in a long time. So they're at approximately the same longitude as we are in Kentucky, but they are close to an ocean, which is moderating their temperatures. So they have, in a certain sense, way nicer weather than we do. However, last summer it was incredibly hot there. So they're filtering all their water and reusing it. Such high efficiency. This is more pictures of water silos. So they would be collecting the water off of these greenhouses, storing it in silos or above ground tanks, and using that. And they do treat the water so it's pathogen free. And I don't know, somebody asked me, how do they get the stuff out of it? Like, wouldn't there be contaminants in it? I actually don't know. So. They talked about their distribution of their food and how they produce much more food than they need in this tiny country. And so they kind of have an open door to all of Europe with being part of the European Union. And so their produce is mostly being shipped to European countries. Although I think I have seen some of their certified organic peppers in our farm store in the past. Oh, let's see. So One of the places we visited was a place called Food Valley, and they talked a lot about our society, and I feel like skipping this slide at this point. They talked about there. This is more information from Food Valley, and some of these are exact quotes from them. The agri-food chain has in every stage world-class companies in the Netherlands. So they were talking about all the things they had to offer. So to a certain extent, some of this trip was like a giant sales pitch, like they're telling us about what kind of seed technology that they have, their processing equipment, how they transport things, the ingredients that are used to add to foods, or how they manufacture. So they're manufacturing the glass and the steel and that would be used in these greenhouses. They talk about helping you market and brand and retail your product, and how to associate with your consumers. Not particularly science. Maybe Quinn can use some of this in his. One of the universities we visited is Haas University, and I found this interesting just for the sake of talking about how many people are going to their college and ag-related businesses. So you might not think about these things as being necessarily agriculture related, but all of these things are in their own way agriculture. So you've got a section here for horticulture and arable farming, and so this is based on the years that this university has been in business, and you can see that there's a huge growth in the number of people attending college to look at some ag-related things, and yet they still say they don't have enough people involved in agricultural production. One of the researchers there made the statement, like, agriculture isn't very sexy. People want to go into something else. And so they are actively trying to get more people to come to the Netherlands to do agriculture, because much like the United States, their farmers are getting older and older, and younger people aren't getting into agriculture. And you look at this, but people want to go into the media and design more so than production, because it's much sexier to be in media than it is to be the grunt farm worker out there. So, it's probably more interesting to be in. Venlo, that's just one of the universities. So they've got different, so that I'm slightly confused about it too. Yeah, it's not an area of research so much. I think I'll pass over this. So one of the places we visited was Koppert, biological. Oh, wow, this one came with effects here. So Koppert Biological Systems, Koppert has distributors and producers in the United States. I think there's one in Michigan, and I'm forgetting where else. I might have it listed on here. So we went to their headquarters. So these are the people that are figuring out what species of bees you can raise in a laboratory and then ship out. So it's very technical, trying to figure out and predict how many bees they need to raise so that they can ship them out in a timely manner. So you can pre-order your beneficial insects, whether it's pollinators or things that control thrips or things that control aphids. And they of it in and of their own business there are doing all kinds of research. So I didn't really think about it before, but after talking to them, you can't just use the same biological organisms, whether they're bacteria or insects. I can't just use the same insect in the Netherlands to control my pests that I can use in the United States, because it's not legal to import those insects, because they could cause all kinds of biological havoc here. So this is some pretty advanced research, and so they have clusters of research in different countries so that they can provide the insects that are appropriate for that country.
This person that started this, I guess, was highlighted in the article as his doctor said you're allergic to the pesticides you're applying, and I guess that prompted him to get into this stuff. So, just a reminder about that.
We're discussing it.
Okay.
All right, and we have some more information there. I think I won't read over it, but yeah, I do. Let's see. So we more. I'm like, oh, I'm out of order. So we do have more about the Wageningen University. This university talked just basically about the different kinds of research they were doing related to. And one example is using the lighting. I don't know what that little sensor was there. I actually took that from one of their slides. So they're looking at how you can grow the maximum amount of produce in the most economical way. And that's what I heard everywhere I went. They do want to know what's the maximum amount you can grow, and also without wasting anything. So if I recall correctly, they want to have zero waste nutrients entering their environment. So whether you're growing in a field or you're growing in a greenhouse, they're going to have nutrient budgets. So if you're planting a crop in the field, you should only be applying exactly the amount of nutrients to that field-grown crop that you will take off when you harvest it. And that if you're growing in a greenhouse, in that little video clip at the front, they talked about how they were once using the largest amount of fertilizer of anybody in Europe. Well, they don't want to have any excess fertilizer entering waterways, entering the ocean. So they have extremely strict mandates about that now. And they intend to have zero excess fertilizer being applied anywhere in any of their agriculture by 2030, I think, which is a very lofty goal. And when we talk about, so one of the examples that they talked about there, and that is, I think you would find interesting for plant science, that over a 30-year period of time, their yield of tomatoes, the hothouse or the greenhouse tomatoes, doubled. And they said that part of that was due to breeding. So you've got one group of researchers doing breeding, and they're separate from the other people, which I find very strange. But I guess, you have to specialize. And the other part was about lighting and studying how day length and the wavelength of the light affects your plant growth and productivity. And it also affects the nutrients. So your light can also affect the nutrients and the flavor of your crops. Computer modeling is now used there a great deal to even start the research. So you can make some predictions using computer technology, doing programming, and then you have less research to do. I'm not the PhD yet, but maybe someday I will be. So I can't describe exactly how that works, but so say they would talk about a new plant they're developing, maybe this plant has a certain leaf structure to it, and they could make a computer model of this plant with a certain leaf structure, and they could decide that plant's bad already, and not even try to put that plant in their research studies because they know that it's not going to be a good variety because its leaf structure has too much shade, it takes up too much space. They're not even going to study that one. And then they would choose other ones that are more amenable to being used in the greenhouses. They use, we might use sensors. I think that Dr. Hall said that you've used sensors to determine photosynthesis in plants. Was that what you did, the spinach? So if you just do photosynthesis of one leaf in a canopy and you're researching it, you do not have the photosynthesis capacity of the entire plant. You only have the capacity in that one leaf. Well, if sunlight is shining on this one leaf, it is going to be photosynthesizing differently than a leaf in the shade. So they can assess the photosynthesis rate of the entire canopy, and you can do computer modeling about shading in the canopy to decide where you would want to put your sensors or to get the best data. And they also do research into, say basil is one that I'm very familiar with. When we cut basil and we take it to the farm store, I'm like, do not put that in the refrigerator. Does anybody grow basil? Have you ever put it in the refrigerator? What happens to it? Okay, so that's chilling injury. And so they're trying to develop basil that will tolerate being too cold. Because you can't ship basil with anything else because it just gets too cold and then it turns black. So they have to ship basil separately. So they look at that kind of thing. And chilling injury affects things like basil is probably one of the most remarkable, but chilling injury affects things like peppers and tomatoes, changes the flavor, causes them to pit, or not hold their shelf life as well. So they're looking at the genetics and lighting impacts, that sort of thing. It's pretty amazing the number of different research topics that they're looking at to make the products last longer on the shelf or make them easier to ship, make them so when you clip off a produce from the vine, does that produce bleed out sap and then start to decay, or does it just heal up really quickly? And maybe changing your lighting in your greenhouse before you harvest it would change how that plant reacts to the harvesting injury. And those pictures are awfully blurry, but you can see one of the things that they have determined definitively is that diffuse light is better in a greenhouse environment than direct light, because as you see in this direct light, there's a lot of leaves that have bright sunlight on them, and then there are leaves that are in the shade, and when you have more diffuse light, you're actually getting more consistent photosynthesis in your entire canopy, and that way your production is going to be better. So I've always noticed that in the high tunnels, our plants grow a lot bigger. It's diffuse light under that plastic. I can actually select which plastic I buy. I can buy a special plastic that will make the light more diffuse instead of direct, and I will get higher production. If I tested it, I could probably find out, but it's something that they've tested and that they've found is accurate. Oh, let's see. I think I just have that there because it's a pretty picture. No. Wrap it up. Okay. see here. So much. I'm on slide 53 of 75.
Yeah, that you know, yeah,
International students, yes, they do. And I have the statistics somewhere about how many, but they do. And tuition is relatively low, like I think about $2,500 a semester. And they do accept international students from the U.S. A large portion of their international students are from China. But actually, let's see. And look, it's tomatoes. So this is what I was talking about, the tomatoes, how they wrap the stems around, and they're trying to correct. It's a pretty interesting thing. The basic benefits of protected horticulture: increased production and resource efficiency, less disease, better opportunities for biological control. Product safety is another one that you'll hear about in protected horticulture. The Netherlands does put their technology out into many other countries, and they talk about, like they would call the big giant greenhouses, they're more like a plant factory. So if you've heard of App Harvest that's going in Moorhead, that's a plant factory. So we have the low tech to mid tech. We use floating row cover in fields, and we have high tunnels, and we have some fairly low tech greenhouses. So we're like low tech and mid tech. And you did get higher quality produce and more production with that higher quality facility. But they do look at adaptive greenhouses for different parts of the world. So like Wageningen and the businesses in the Netherlands don't just say, oh, we're just doing this for the Netherlands. They're going to Indonesia and the US and all over the place and really researching what greenhouses are going to be best. And they don't want to do something that's not going to be successful. And they talked about, the different, so, you're not going to see this in the Netherlands, but you might see that in a different country. And they're going in, so these are in little grow bags, but it's still high for its area, it's appropriate technology. Another thing they talked about that I should probably mention is the robotics in horticulture in their greenhouses, and just the fact that human beings don't really want to pick peppers all day or clip leaves off of plants all day and sweep them up off the floor. So there's varying degrees of using robots to do this work. Does anybody think it sounds appealing to pick tomatoes all day long, 8 hours a day? I mean, like, really? It doesn't. My job is very varied, but they're talking about using robots to monitor your pests, monitor your beneficials, using some drones inside these huge greenhouses to monitor the crops and check for problems like an outbreak of botrytis, plant disease. They're developing, so there's problems in its natural environment with vanilla, and so in the Netherlands they're trying to start raising vanilla in greenhouses so that we can continue to have vanilla. Eyes off. Skip that one. Skip that one. I looked at a Florin tree nursery. We went to visit this place, and they had developed a soil scanner that they use to help with using precise application of fertilizer. They also developed nip trees, although they didn't patent it, so everybody has nip trees, or they call them nip boom trees. They use GPS to analyze their yield and the quality of their crops. A really interesting note that I had no idea of: if you're raising rootstock, like tree rootstock, you're never supposed to grow more rootstock or baby trees in that area for the next 100 years. So this company is growing like 60 acres more on new land, like leasing the land to grow their tree crops that they then sell the trees to various places around Europe. I forget what they called the disease. It just causes them to not grow right. And aha, the nip trees. So the nip tree, so they'll grow out a rootstock. This says April, and I realize it's not clear enough to read it. So they grow a rootstock for 1 year, and then they take scion, the fruiting part from another tree, and they attach that to the rootstock, and then they plant out this. So they'll graft. They dig up the rootstock, and they graft this, and then they replant the rootstock with the grafted scion on it, and then they let it grow, and then they cut it off to a certain, well, this is 65 centimeters. They cut it off, I don't know, would that be this tall? They cut it off, and then it sends out branches, and they let one of those branches grow stronger, and they're producing fruit way earlier. Exactly how much earlier? It's like within 2 or 3 years, they've got a smaller tree that starts producing fruit earlier, and by 5 years, these trees are producing a large amount of fruit. I don't know if this is being used in the United States. I don't know of it being used. I've never heard of it.
Yeah, I don't know. I mean, I've heard about a lot of the rootstock from dwarfing and getting things a little bit quicker, but
yeah. So this is just like they're just totally cutting off the whole top of it and then letting it regrow, and you can kind of see it. I didn't see them in person. They had some posters on their wall about this, but it's not a big deal there. So they do talk about exactly how they do it in this. I stole this from the internet and looked at somebody else's description of how they make these nip boom trees. So you get higher yields and you get your yields faster with this. You did notice there's 40 U.S. varieties produced there. And I'm like, we should learn about that, shouldn't we? And this guy also developed a remote monitoring, basically a weather station and field monitoring system called a walkie-talkie. The cloud in the Netherlands is called a cloud is walkie. So it's like a cloud talking machine. So they, with assistance from the university, researchers, there's a team of students like you, and they'll get a project like this, and they'll help develop this kind of technology. So this grower might have the idea, and he contacts the university, and then a team of students work on the actual real live problem that this grower has an idea for, and they develop this, in conjunction with each other. So this device, you can use it to monitor the soil moisture and the temperature in the canopy, and this is Chinese or Napa cabbage in the field. This was last summer. It was an extremely unusually hot summer. And when the temperature inside the canopy or the soil reaches a certain point, the irrigation turns on. It allowed this farmer to save his crop. Otherwise, this would have bolted. So, and this has basically cell phone technology in it that calls up, like you can check what the weather is like out there, but this automatically turns on a watering system when you reach that point. So it might have watered this field for 5 minutes every hour or 1 minute every half an hour to keep the water, to keep the irrigation perfect, so that it was the difference between a crop that was marketable and good quality and no crop at all.